So I'm going to talk a little bit about migrating to cloud and some of the lessons from the Netflix cloud journey and a few updates on this. 2008, we had a shock. We had a 2-day outage where we didn't ship any DVDs. It was because IT had assumed that they could make the systems perfect and developers just didn't have to think about hardware availability. Everything was just going to work. They were going to buy high-end hardware, high-end software, make it just work, and we could just implement our software over the top and just assume that the stuff underneath was going to work. Had a silent data corruption in a SAN. It just corrupted all the databases. We restored everything. It corrupted them again. And the whole thing was a big mess. What happened out of that was a change of assumption. We questioned this assumption. Maybe availability had to be handled at the application level, and it had to be a concern of the developers. And we had to bring it right up there and think about it. And then if we were doing that, could we use low-cost cloud infrastructure to go and build that rather than this very high-end, very curated, expensive hardware? We could use off-the-shelf, low-cost, ephemeral hardware. And that was the mindset change that came through. So this was quite often I see when people are moving to cloud, there is an outage or a thing. There's some major kick in the butt that happens to management that they start questioning assumptions. So that's the beginning of a lot of cloud journeys. Added to that, there's usually an existential threat. And for Netflix, it was that we needed a massive increase in data center capacity. We couldn't tell how much, where we'd need it, and we didn't have time to build it. It takes about 9 months to provision a data center, and we had no idea what our capacity needs or where we were going to need it in 9 months' time. And it was because streaming was replacing DVD. This is happening across industries. We're seeing systems engagement dominating IT. It used to be that IT was about looking after employees and factories, and maybe point-of-sales terminals and things like that. But you didn't have your IT system scaled with the number of customers or shops or factories you had. It didn't scale with the number of customers you had. Now, because our customers are directly connected to our systems, sort of whether you call it IoT or direct marketing or whatever, we know about all our customers. So now we have IT systems scaling with the number of customers you have. And that's why systems of engagement are overrunning everything else. My other favorite example is, why is Netflix like BMW? People go, why? What's he talking about? BMW make cars. And it used to be that once a year you would take your car in for service and they'd probably get an update saying this car is now at this mileage and we fixed this thing and whatever. Once a year you'd get an update about a car you built. The current cars are directly connected through an AWS service back to BMW. They know exactly where they are downloading map updates. They are using the car as a sensor. This thing is called Carasso. And it's a car as a sensor. They're finding out about roadworks as they're happening. They're finding out about congestion as it's happening and sharing it across their customer base. They're also collecting a lot of data about how these cars are driven. So think about how much traffic that is back into the central systems compared to seeing a car once a year, scaled across all the cars you've ever built. I mean, right now this is only in the sort of 7 series and working down the range. But that's what I mean by systems of engagement dominating IT. And you can pick an industry, you can look at how the internet has let us connect directly to our customers. So the DVD business for Netflix looked like this. Every once in a while, you would say, I'm going to pick up some DVDs. Maybe on every Sunday night, you'd say, these are the DVDs I'm going to watch next week. And you'd put your DVDs in the mail, and new ones would come next week. And next weekend, you'd actually get around to watching some of them. And then you'd do it again. So the interactions were roughly once a week, a little bit of browsing. So we had a system set up to support this. And we had a decent-sized machines and whatever. But it wasn't really huge. Then, if you look at the streaming business, people start binge-watching, a whole TV series in a day, and then they'll watch another one, then they'll watch another one, and the system isn't just picking them, it's logging the data. It's giving you quality of services being monitored continuously. There's a progress heartbeat, so if you stop halfway through something, they know where you are when you resume. There's a huge amount of traffic going into the system compared to the DVD side, right? So what we found, if we just make some numbers, it's about 100 times more views per week. It's maybe 10 times the views per week and 100 times the number of requests per view. even if you just take those are pretty conservative estimates. That means it's 1,000 times more traffic for every customer that stops using DVDs and starts streaming. Right? So as Netflix shifted from a DVD shipping company to a streaming company, this is what happened. That's our DVD capacity. That's our streaming capacity. The point where we were spending half our capacity servicing streaming was when 0.1% of our customers had started using the new capabilities. Right? That was when we had 50-50 in our front-end web services and API services, when we'd hit 0.1%. So this is why we were going, we have a problem here. We're going to be the next Twitter fail whale, internet meme, and we needed to figure out how to deal with this. So that gave us a choice. Either recruit world-class data center operations people, guess the capacity we'd need, and build a huge data center and put a huge amount of money up front into building that data center infrastructure. We're talking tens to hundreds of millions of dollars sized data center investment here. Or use AWS, where we could pay for it the month after we used it and put that hundreds of millions of dollars into content that made the product better. And that's the choice, right? And obviously the choice they made was, hey, let's go buy another season of House of Cards instead of building a data center. One of those makes your costs slightly lower, perhaps, if you do it exactly right, and the other one moves the business forward. That's the choice, and that's the big choice that lots of people are making now as they decide they shouldn't be spending time building data centers. So, in 2009, I wanted to mitigate some risks. First of all, understand how AWS and Prime were related, and they were separated. There was a phone call between Reed Hastings, the CEO of Netflix, and Jeff Bezos, the CEO of Amazon, to just, what's this AWS thing? And is it really separate? And they're not going to feed all our data into Prime and all that kind of stuff. They got comfortable on that. And then ever since then, Netflix has been used as the example by AWS of, yes, you can run your competing business on AWS, and it's fine, and Netflix does it, and other people do it, and you shouldn't worry about it. The way Netflix thought about it was that we were going to use the strength of our biggest competitor against them. It's like a jiu-jitsu move, right? You tip over, use the weight of your opponent to make them fall over. So Netflix, it turns out, used AWS better than Prime ever did to compete with Prime. We did a whole lot of capacity experiments. One time we went, I wonder what happens if you ask for 4,000 machines at once. Well, get an autoscaler set at 4,000 instead of, before that we'd only tried 100 or so at a time. And about an hour later, 4,000 machines were running, so that was good. Now, this is in 2009. It's much easier to do that now. But at the time, that was transformational. The idea you could create 4,000 machines in an hour just by asking for it was crazy. We signed up for an enterprise license agreement because you don't want to be running a major business on a click-through license and a credit card, it turns out. And this was the first time AWS actually had an enterprise license agreement. It was sort of created by the first few big customers going, hey guys, no, we're not doing this on a credit card and a click-through. And we did this publicity story in the New York Times that was kind of the launch. The results of the story were people thought we were crazy at the time. There's no way we were ever going to make this work. That was the prevailing opinion. First thing we did, try out some things that were not customer-facing, that were not critical. We were coding movies, and we didn't have enough capacity, so we moved it to EC2. That's where we grabbed these 4,000 machines to process this. It worked fine. And then once we'd processed them, we shut them down. And it costs the same amount to have 4,000 machines for 1 day as to have 1,000 machines for 4 days or 100 machines for 40 days. We had 100 machines before, and our backlog was a month. So we shrunk it to a day by just having 4,000 machines. See? Finally, the next thing was all of these streaming services were logging back into the system, and our database that was handling the logging of the quality of service just got overrun by all the streaming capacity. So we moved it to S3, which is a really unlimited storage space. Just to give you a reference point more recently, we just ran a benchmark where we created an exabyte-sized bucket in S3 just to run a benchmark. An exabyte, that's 1 billion gigabytes or 1 million terabytes, right? Okay, we can talk about the actual thing itself, but the fact that we had a spare exabyte just to run a benchmark tells you that this is quite large. And some of you might have an exabyte, and we have customers with exabytes, but it's quite big now. 2009, it probably wasn't quite this big, but it's huge. So unlimited space, and we moved log analysis, and we used Hadoop to process this. This is in 2009 using the EMR. This was one of the first times where we said to Amazon, you've got the wrong version of Hadoop, and we need this Hive thing, and we need these feature set. And they went, OK, we'll build it up to the versions you wanted, and then we said, if you do that, we'll use it. So we they built the version based on our feedback to make it a usable stack of things to solve our problem, and then Netflix has used it ever since. So that's part of the feedback loop, and we do that with our customers all the time. We say, well, really, we'd like this thing and these features, and we go, OK. We talk to a few more customers, pull it in, and that customer obsession, that's what AWS runs on, and that's why there are so many products coming out from us. So, start of 2010, we decided not to build any more data center capacity, so we had to move to the data center by the end of 2010 to survive. So we kind of went through, and we kept converting front ends out, move front ends out to the cloud, and by the end, we had our back ends had grown to fill all the space that was created by moving the front ends out, and our front end was huge. While we were doing this, we had this nice slide that we showed internally. It's like, we really have a deadline on this, because we are not going to build another data center. And Netflix, you got a choice. You either go to fly in the cloud, or you're going to hit those trees at the end of the runway. There's a limited runway problem. We knew there's a big increase in capacity need to get through the end of the year, and we weren't going to build it out in the data center, so we had to move to cloud. So this forced March conversion was one of the key things that made it get done, right? It's another thing I see when people are doing cloud migrations. You set a real goal target. This data center is being closed here. It's out of lease. It's being shut down. You've got a hard stop. Those kinds of things are what get these transitions to happen. We started with the simplest possible API service, then the simplest web page, and then just APIs and pages one by one. And we did it by just doing redirects. So you'd hit hit the data center, and it would choose whether that page existed in the cloud and whether you were in the right test cells and things, and what percentage of the customers we want to send there, and just redirect traffic. So it's just redirects, HTTP redirects, and that worked fine. Eventually, we had to move data, so we start copying some data back and forth. And nowadays, we have some tools called Database Migration Service, which will actually continuously copy data out of things like Oracle or Teradata or MySQL SQL Server, proprietary databases in particular, and you can use them to migrate to cloud. And you can move them to Postgres or MySQL or DynamoDB. Now, in 2011, we decided, OK, we're going to shut down the data center as the system of record and move to the cloud as the primary data source, so we needed to be able to back it up. And we wanted to replace our offsite tape backup, so we created a separate account in a separate region. And that became a very secure, durable way of doing this. And we set it up so it couldn't be deleted. It was automatic purging. And nowadays, there's long-term archive using Glacier. So we replaced this offsite tape backup with, put it in another region in another account. Do you want to be guard against account takeover and a whole bunch of other internal sort of disgruntled employee kind of things? You want to make sure your backups are really impregnable. But this replaces tape backup as a mechanism. Finally, all in, they closed down the last data center. This happened after several years.